Howdy, AP PreCal. I think this may be the last video I make from Mr. Passwater's Unit 3. It's his multiple choice. I see 1, 2, 3 pages. Okay, let's see what we can do. As always, I have not looked at these problems, and also I am not quite in this headspace. So you get to watch me think through this. And I have never taught rates of change in polar functions in my 24 years of teaching. Well, in 23 years, this 24th year, now I have taught it. But it doesn't necessarily come quickly and easily. So that being said, I'm asking for a little grace. All right, here we go. In the which of the following statement is true about the distance from the point with the polar coordinates and the origin? Okay, the distance is increasing. Okay, so here's where, do you know what? I think, if I remember correctly, this is one where it might help us to graph it as a rectangular function. Let me grab. Okay, let me get some scratch paper. What we'll look at here is if I were to graph y is equal to 3 cosine x plus 2, what does that graph look like? I'm going to go up 1, 2, 3, 4, 5 is the highest that I ever am. My midline is at 2. I go as low as -1. I'm back here. I'm back here. And so this is my rather poor attempt at graphing this function. Okay, so we need to know where does it go from positive to negative. And that would be, okay, so if I set this equal to 0, oh, this is not going to be unit circle friendly. Okay, well, so this is 0. This is when theta equals 0. This has a value, a y value of 5. We are at, this would be pi over 2. I don't know what I'm writing. Pi over 2, comma 2. This would be pi, comma -1. This would be 3 pi over 2. That's a 2, comma 2. And this would be 2 pi, comma 5. Okay. So yeah, these, right? Yeah, -2/3 is not unit circle friendly. So the fact that he's talking about these things makes me wonder if he had intended it to be unit circle friendly. I don't know. Okay, let me see. If we have 3 cosine x plus 2 equals 0, we have cosine of x is equal to -2/3, which we can do. We can solve that. We just don't know it without a calculator. So whatever those two values are, that's great. Okay, so the distance, so where's 5 pi over 6? Well, y'all, I wonder if this is one of the ones that he changed. It wouldn't, or if this is something he has changed since I printed it. It wouldn't completely surprise me. Let's see, if I plug in 5 pi over 6, then I have f of 5 pi over 6 would equal 2 plus 3 cosine of 5 pi over 6. Where is 5 pi over 6? It's over here. The cosine value is a negative √3 over 2. Okay, and so this becomes, oh, I think this is likely to be negative. So this is 4 minus 3 √3 over 2. Without a calculator, this is kind of annoying. √3 times, now I don't know. Let's see. Oh, and I just grabbed a dead calculator. Let's see if I can find one that has batteries. Okay, here we go. If I have 4 minus 3 √3 over 2, I'm thinking it's negative. Oh, thanks, calculator, that helps. It is negative. Okay, so this point is negative down here somewhere. It's going to be 5 pi over 6. So somewhere here. And then, so, okay, so from 5 pi over 6 to pi, they are negative and they are decreasing. So when the distance is increasing because it's negative and decreasing on that interval, I think that's true. Because the way I remember this is a negative and a negative gives me a positive. It's not exactly how that works, but it kind of like well, if you think about it, we were this far away from the pole, and then we're getting farther away from the pole right there. Okay, where is 4 pi over 3? Oh, I don't know. 3 pi over 2 is here. 4 pi over 3 is probably over here somewhere. Well, if this is 5 pi over 6, 7 pi over 6 would be also negative. Okay, let's see, positive and decreasing. It's not positive and decreasing. So it's on the other side of pi. It might be, whether or not, it might be here. So it might be positive, but this is definitely increasing. So that makes this statement wrong. 5 pi over 6 to pi, it's negative and increasing. No, it's not increasing, it was decreasing. 4 pi over 3 to 3 pi over 2, it's positive and increasing. Okay, yes, possibly. We don't know exactly. I think it's positive. I think it's probably here, but we don't exactly know and didn't really want to do the calculations. But positive and increasing would not be decreasing here, so that makes that wrong. So I see that that one is equal to A, but that was tricky. Very good, very good. Okay, so let's look at the next one. We have, which of the following intervals is the distance between the point with the polar coordinates and the origin decreasing? Okay, let's see. Does this one give us, if I were to graph this, goodbye, I'd have y is equal to negative 4 sine of x plus 2. Okay, so what is my graph doing? I start at 2. I go down first to negative 2. I back to 2 and up to 6 and then back. Okay, so we're doing something like that. The question is, where did we cross? Let's see. If I take negative 4 sine of x plus 2, set it equal to 0, subtract 2, divide by negative 4. Oh, okay, I get sine of x is equal to 1/2, which made sense to me. When does sine of x equal 1/2? At pi over 6 and at 5 pi over 6, which makes this would be pi over 6, and this one right here would be 5 pi over 6. Okay, and so this is pi over 2. This is 5 pi over 6. We're still increasing all the way up to 3 pi over 2. Can you see? I'm writing very small. Okay, so then they're asking what is happening which of the following intervals is the distance between the points with polar coordinates and the origin decreasing? Okay, so we want it to be either positive and decreasing or negative and increasing. Okay, pi over 6 to pi over 2. That is negative and decreasing, so negative, they're getting farther away from the axis, so no. 5 pi over 6 to pi, here's pi. They are positive and increasing, that's getting farther away from the axis, no. 5 pi over 4 is going to be here. To that, so those are positive and increasing, so that's a no. 5 pi over 3 to 11 pi over 6, so here and here. And yes, those are, it's positive but decreasing, that's going to be our answer. It's amazing to me how much the rectangular curve helps me answer these questions. Is this the only way to do it? No, but that's what works for me. Okay. Which of the following intervals is the distance between the points with polar coordinates in? Oh, this is interesting. These are not equal, but these are equal. So I'm not sure if that was on purpose or I don't know. Okay. From 0 to 2 pi. This is, oh, it's not a rose. The one does weird things. Yeah, I'm not sure what that looks like actually. But let's graph this as a rectangular function. If I have y is equal to negative 2 cosine of 2x plus 1, thank you. Then we are going to start at the very bottom. It would be negative 2, but we've moved up 1, so we're at negative 1. And then we get to our midline is 1. We get to the top would be 3. We're back to the midline. We're back here. That happened because of the 2 right here. This happened. This is pi negative 1. And this was pi over 2, 3. So we're doing this sort of thing. And then I can draw another period of that because it does tell me to go to 2 pi. Let's see, where does this have zeros? What are our zeros here? Negative 2 cosine of 2x plus 1 equals 0. Cosine of 2x, I subtract 1, divide by negative 2 equals 1/2. Cosine equals 1/2 at pi over 3 and at 5 pi over 3. Oh, okay, I was like, wait, that's not going to fit in here, but this is why I slowed down. Pi over 3 plus 2 pi k. We might want more of them. And then it also is true at 5 pi over 3 plus 2 pi k. But I had to divide everybody by 2. So x would equal pi over 6 plus pi k. And x would also equal 5 pi over 6 plus pi k. So this first one right here is pi over 6. This next one is 5 pi over 6. And then we'd also have one at 7 pi over 6 and another one at 11 pi over 6. So that's the part that I didn't graph. We'd have zeros at those. Okay. Which of the following intervals is the distance between the point with polar coordinates and the origin increasing? So we want to be positive and increasing or negative and decreasing. 0 to pi over 6, we were negative and increasing, so no. Pi over 2 would be here. 5 pi over 6 would be here. We are positive and decreasing, so no. Pi to 7 pi over 6. Okay, so 7 pi over 6 was our next 0. So we are negative and increasing, no. 7 pi over 6 was here. 3 pi over 2 would get me back to the top, and that is positive and increasing. So positive and increasing, yes. We should look into this and see why the difference between not equal and equal. But I luckily don't have to choose between that and one where they're soft brackets, so I don't quite know. If you know, feel free to comment below and tell me how that works. Or, yeah. Anyway, that was fun. Okay. We have this one. The graph has no holes, passes through, on this interval of theta, the graph has no holes, passes through each point exactly one time. And as theta increases, the graph passes through the labeled points A, B, C, and D in that order. A, B, C, and D. Okay, that doesn't surprise me. On which of the following intervals is the average rate of change with respect, oh dear. Okay, let's see. Average rate of change is going to be, okay, so at A, let me make sure. Okay, we started at A, we went to B. Those have, I think they're going to have, okay, so it's average rate of change is going to be f of theta 2 minus f of theta 1 over theta 2 minus theta 1. And so it's the r value, which it looks to me like the r value here would be about 3, maybe, yeah, 3. And then this becomes a minus, and then this is our second, okay, sorry. If I'm looking at B, if I'm looking at A to B, then I'm going to do B minus A. So I have a negative 3. No, that's not going to be negative 3. It's going to have a, this looks like to me, oh, you guys, I should go look this one up. It might be 3 minus 3, because this is a radius of 3, this is a radius of 3 over, this angle was 0, but this angle was maybe pi minus 0. Okay, and so that's 0. Okay, B to C. The C radius looks like it is, this is 6, so maybe it's 5-ish, and the B we said was 3, so this would be 5 minus 3 over, what is this angle? It appears like it is 1, 2, 3, the pi over 4 family, so 5 pi over 4 minus, we thought this looked like pi, so 2 is being divided by pi over 4. So this would be 8 over pi. Well, that's bigger than that. B to D. Oh, dear. Okay. B to D. I'm looking at an angle, whatever. I'm calling this 5. I don't know that it is, but I'm saying this is 5 minus that radius was 3 over, this value is going to be at 7 pi over 4. And this one, B right here, is still at pi, minus pi. Okay, so 2 is getting divided by 3 pi over 4. So this would be multiplied by the reciprocal, 8 over 3 pi. Well, if I take 8 and I divide it by pi, that's going to be bigger than if I divide it by 3 times pi. Because it's like 8 divided by 9 versus 8 divided by 3. Not exactly, I know I'm estimating, but I'm trying to make this make sense. So this is still the smallest, B to D. So I did D minus B and C. And now everything changes if I have negatives. So, okay, on which of the following intervals is the average rate of change with R, a change of R with respect to the least? Oh, so far it's the one that's 0, but I'm gonna have to go look this up, you guys. Okay, D to A, well, so I'll take the A and then subtract away the D is how I keep doing this. So 3 minus the D value was this 5, and this was A. A would be back at 2 pi, I think, minus the D value there was 7 pi over 4. Okay, so now I see a negative 2 divided by pi over 4, which is equal to negative 8 over pi, which would be the smallest number that I've seen. The numbers I saw were this, 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 and this, if I did things correctly. I'll go look up this answer key and see if I'm right. If I'm wrong, I'll make another video. If I'm right, then we got lucky. Okay. Which of the following? You know what? I don't want to do this one until I look through the next one. So maybe I will make another video, see if I'm right, figure out this one ahead of time. Y'all, ew, okay. Almost done. How is the distance between the origin and the points of the polar graph changing? Okay, so what I'm going to do is I'm going to come along and graph this, and I'm doing this, from pi over 4. So this was pi because the period changed. So this is pi over 4 right here, and this is 3 pi over 4. So it did, so the parent function did that. Oh, so it increases and then it decreases. So it's increasing until pi over 2, and then it's decreasing beyond that. Huh, okay. Good to get my confidence back. Okay, let's see. Consider the graph where the polar is true over the interval. Oh, okay. I need more paper. Okay, so looking at this one, if I graph this as a rectangular function, what happens, we start in the midline, which is 1. We go down first. We go up. We've seen this already. So it's something like this. Where are my zeros? You know what? Didn't we do this? No, not quite. Oh, I sort of did. Okay, I think that's terrible. I think this one right here is going to be pi over 6, and this is going to be 5 pi over 6. But just to make us all happy, set this equal to 0. Subtract, divide, sine of x is equal to a positive 1/2, which is, sine of x is, that's at pi over 6 and 5 pi over 6. Okay, I was right. So now what is it saying? So where's 2 pi over 3? 2 pi over 3 is going to be somewhere over here. And 3 pi over 4, hang on. 2 pi over 3, 3 pi over 4. You guys, it's the end of the year. I'm getting tired. This is 2 pi over 3 on the unit circle. This is 3 pi over 4. And this is 5 pi over 6. And what were they comparing? 2 pi over 3 to 3 pi over 4. Okay, so we're here and here, which is inside this bit here. Because this, let's draw this again. No, this is at pi over 2. These two values are in here. Okay, so they are negative and increasing. So we want negative. They're negative and increasing, which means that the distance is getting smaller. The average rate of change, oh dear, is positive. The average rate of change. Well, if it's increasing, the average rate of change is going to be positive. So I think we can eliminate that. Yeah, this is tricky. Okay, let's see this one. And the points on the graph above are above the x-axis. Oh, no, they're below the x-axis when it's graphed in the xy plane. Okay, so are below, I think it's this one. Maybe I should go check the answer key. Yeah, I'll come back and try and check these last 2 pages. I'm keeping them separate from everything else. Okay, very last one. Okay, we have this one on the interval from pi over 2 to 3 pi over 4. The points on the graph are below the x-axis and getting farther from the origin. Okay, here's what I see. One, I don't know how to graph this rectangularly immediately. I do know this would be like 2 sine theta cosine theta plus another sine theta cosine theta, which is sine of 2 theta plus sine. I don't know that that helps me though. This would be half of sine. Well, okay, if this is half of, if this is half, I don't know the best way to do this problem, but I know that this is now half of sine of 2 theta, which 1 plus 2, this is 3 halves times sine of 2 theta is my function. Is this helping me? Well, I don't know. I can graph this though, and so when I graph this, it still has, it's coming up to 3 halves, it's coming back to 0, it's going back. Now I know how to graph this. This happened by pi, and so this is pi. This is the point pi over 4 comma 3 halves, and where are we here? This is pi over 2 comma 0. Where were they saying? Pi over 2, and this is 3 pi over 4 comma negative 3 halves. Now I'm really curious. Did anyone else do this problem a different way? If so, comment below or give me a link to make your own video and show me how you did this. What I'm seeing is this piece of the graph. The points on the graph are below the x-axis and getting farther from the origin. In the xy plane, they're getting farther from the origin. They are getting farther from the origin. And they are below the x-axis. I think it's this. Okay, you guys, point being, some of these polar questions, they have found the trickiest ways to ask stuff. So I'm going to teach this better next year. That's guaranteed. But in the meantime, like, subscribe, comment, tell me what you learned, what you liked about what I did and what you didn't like. And then let me know how I can help you. Go practice and best of luck to you.